You're going to have to be able to do for the test coming up. That's in week 3, the Wednesday double. So far, you have done the simplex algorithm over and over and over again. Okay? And the solutions were all integers. What does that mean? Whole numbers. So these scenarios that you've dealt with in the exercises so far deal with discrete variables. What does that mean? They must take whole number values. So tins of power boost. You're not going to sell someone half a tin of power boost. Okay? You're not going to have less than one of a person. But that's not always the case. The variables do not always have to be whole numbers. For example, do I have to have a whole number of liters of something? Do I have to have a whole number of kilograms of something? You can't have third cup measures. You can have quarter cup measures. So variables like these can be expressed as fractions of a whole. Variables like these are known as continuous variables. So you need a way to deal with continuous variables, and here it is. There is nothing different in the first 2 steps. Step 1, look at the scenario. Step 2, do the 6 steps of the simplex algorithm as normal. The only place where it differs is once you've drawn your little graph and colored in your little triangle or whatever, your lines might not sit on the corner of a grid line. So you're not going to know whether it's, 4 or 5 or 6. You're not going to know exactly where it is. So step 4, you check where those vertices are using simultaneous equations, which I'll show you how to do. And then step 5, you do everything as normal, you just have an extra check in the middle, okay? I'll ask you, please, in the next 5 minutes, can you get the steps and the example down, what you can see of it? Get the steps and what you can see of the example so I can demonstrate in one big go how to answer these questions. And that will be it for this topic. Get the example down as well. If you've got the example, start drawing your simplex, please. I'll do it slightly different today. Instead of me mainly guiding, I'm just going to ask you what I have to do. It's the last lesson. You're smiling and then you frown. You okay? No, I was talking to you. No. You're like, huh?
To him. To him.
You're like smiling, and then when I looked in your eyes, you frowned.
Yeah,
I'm sorry I have the effect on you, that's fine. Yeah, that's fine. Remember, you need the mark from me. And I need to be your friend.
I'm trying to do the
Okay.
most exaggerated frown.
My daughter, when she smiles, it looks like an emoji. It's crazy. You know, the eyes go up. She looks like, you know, the emojis.
Oh,
Yeah. Yeah. Her face goes up. Can we have a look at this example then? Is there any pertinent information provided in the first line of the example? There's no numbers there, so there's nothing important there. Is it important that X costs $8 a kilo?
Yep.
Highlight. Is it important that Y costs $12 a kilo?
Yep.
Yes, sir. We haven't got any info about constraints yet, but can you see in the next sentence, there's the words at least. So there's our constraints there. At least 25 units of A, at least 38 of B, and at least 16 units of C. So we already know. We've got a table written up for us. We can say greater than or equal to 25 for A, greater than or equal to 38 for B, and greater than or equal to 16 for C. And so it's an optimization question. You're finding the combo to minimize costs, find and tell me the minimum cost, so, in your test for drawing up the graphs, you've got about 8 marks for that, so 8 minutes. Based on this table here, I'd suggest you get onto it and practice drawing the simplex for this. And you can already tell that that simplex is not going to be nice, because does 5 divide into 38 nicely?
Yep.
No, so your x coordinate is going to be a decimal. Does 3 go into 38 nicely? No. So that's also going to be a dodgy one. 3 doesn't go into 16 nicely, so that's going to be dodgy. 2 and 4 don't go nicely into 25. So that's why we have this extra check, step 4 and step 3 and step 4, because all of the crossover points in this graph, we don't know. We can't be sure. Okay? I'm going to copy and paste. Oh no, I don't need to copy and paste it. Greater than or equal to 25, greater than or equal to 38, greater than or equal to 16. You tell me, what are the constraints? What is the constraint for A? Come on, if there's going to be awkward silences, I'll stop recording and I'll just post the video from last year. Because teaching you must be a waste of time if you're not going to answer me, yes? What's the constraint for A?
That would be...
Oh, there's a baby. Sorry. What's that?
x2 plus y4.
Say in the right order though. 2x.
Oh, sorry, 2x
Plus?
4y greater than or equal to 25.
Okay, there are other people in this class. What is the constraint for B?
5x plus 3y is greater than or equal to 38.
Someone else that isn't already ahead. What's the constraint for C? Yeah?
X plus 3y greater than or equal to 16.
You've defined the constraints. What is the next step? I need to draw these constraints. So someone help me. What form of line equation are these in? These are in general form. So I need to do a set of steps, which there's a whole friggin' YouTube video of a lesson there of me showing you how to graph a line in general form. How do I do that? A. Say it louder. Say it.
Find x and y.
Good. And how do I do that? I make y equal what?
0.
4 lots of nothing equals 25. So x is going to be 25 divided by 2, which is going to be, I think it's 12 and a half. I think so. Let me check.
Yeah.
It's the end of the day. And then what could I make 0 to find y instead?
X.
Make x equals 0. So 2 lots of nothing plus 4y is equal to 25. Y is going to be 25 divided by 4. It's less than 6. My brain isn't operating the best. 25 divided by 4, 6.25. Put boxes around it so that you know what you're looking at to graph. Can we have another set of people help me graph 5x plus 3y is 38? What do? Do the same thing that they just did. What would I write for my working out?
Y equals 0.
Sorry? Make y equals 0. So what would I write to do that? 5x plus 3 lots of 0. 38. So we've got 5x is equal to 38. So x is going to be 38 divided by 5. 38 over 5, 7.6. And you see, all of these intercepts are sketchy as. They're not going to be nice. What do I write for finding y? Yep.
That's a 5, 0.
Why does that keep happening?
Yeah, so 5
5 lots of 0 plus.
3y
Is?
equals 38.
So y is going to be what? 38 divided by?
3.
12.67. Another sketchy one, sketchier than even before. So then C. You're relaxed from your Spanish trip. You want to help us out? Yep. Yeah. Did anyone else go on the Spain trip?
No, well,
Yeah, see?
I'm not
See
sure,
how-
so-
You're not sure?
No.
Okay. The line that I'm you better be sure by next week. X plus 3y is equal to 16 is what I'm graphing. So I need to find the x and y intercept. So to find the x-intercept, in the equation, I make y equals 0. See, I have x plus 3y. What did I do? I just replaced y with 0. So that's going to tell me x is 16. If I want to find the y-intercept, I'll make x equals 0. So 0 plus 3y equals 16. Y is going to be 16 divided by? Divided by 3 is another sketchy one, 5.33. So we have a bunch of dots here that we can graph. So give me my time. I'm going to do exactly what you're going to do. I'm just going to zoom it out so you can see all that maths. Y 6 point... I need to zoom out even more. X is 12.5, 12 and a half, halfway between 12 and 13. Y is 6.25, 6 and a quarter. That's one line drawn there. That's the A one, so that is 2x plus 4y equals 25. Next line, x is equal to 7.6. So slightly past halfway. And then 12.67, so 2/3. That's the second line drawn. That is 5x plus 3y equals 38. Then the last one, x is 16. Y is 5.33. So that line is x plus 3y equals 16. Does it sort of look like the lines are all crossing at the same place? But based on the fact that our x and y intercepts are all kind of sketchy, do we know that for sure?
No.
We don't know for sure. So what was step 3 and step 4 about? It's checking that, okay? So where is A and B crossing? Well, what you do is make them simultaneous equations. So A was 2x plus 4y equals 25. and B was 5x plus 3y is equal to 38. You remember back to the start of the topic? We had simultaneous equations. What could I do here? I want the number in front of x or the number in front of y to be the same number but opposite sign. What's the smallest number 2 and 5 go into? 10. So what could I times the top one by? I could times that by 5. What could I times the bottom by? Not 10. What kind of a 2? I need it to be negative 10, right? So if I times that 5 by 2, it's just going to be 10 again. I need to times it by negative 2, yeah? So times by negative 2. So let's do that. 10x plus, what's 4 times 5? 20y equals 125. And negative 10x, negative 6y, I don't know what 38 times 2 is. 38 times 2, negative, it's going to be negative 76. We can add them vertically now. If I've got positive 10x and add negative 10x, how many x's do I have left? 0. Good. So it's been eliminated. If I've got 20, take 6y, that's going to be 14y. And 125 take 76 is 49. What's that 14 doing to y? What's the opposite of multiplying by 14? Divide by 14. Divide by 14. Y is going to be 49 divided by 14, 3.5. I've got y, I need x. So I'll substitute that. Which is the easier looking equation out of this one or this one? The top one is smaller numbers. So 2x plus 4 lots of 3.5 equals 25. 2x plus, I don't know what 4 times 3.5 is. 4 times 3.5, 14 equals 25. What's the opposite of adding 14 to something? Minusing it, so 25 take 14. 11. What's 2 doing to x? Timesing. Opposite of divide. Good. So x is going to be 5.5. So we think right now we've done one equation that says maybe it's 5.5 comma 3.5 question mark. Am I sure yet? What could I do? Could I do a simultaneous equation between A and C now? Do the same thing? Could I do a simultaneous equation between B and C? Do the same thing? If you can confirm, then that's all you do. That is the only different step to everything that you've done before. Because right now, this is question mark. We don't know for sure because it's sort of in the middle of all those, okay? Everything else about the algorithm is exactly the same. You just have to do an extra step using simultaneous equations, okay? So your homework now is to practice doing that with exercise 2D.1. There's only 2 questions there, 10 answers involved with that. I haven't finished the whole problem, okay? Because you've shown me you can already do this stuff. You can make your little table. You can do the objective function. What was different about today? Did we have to do some extra checking? That's the only difference today, okay? So I don't want to, you're already all tired. It's lesson 6. It's ridiculous, okay? But if it's a timetable lesson, it's going to be a lesson. So I'll stop the recording.